If we have y equals arcsine of x, another notation for sine inverse and sine to the minus 1 of x, then x equals sine y. And differentiating with respect to y gives dx by dy equals cos y. Then using the result for differentiating inverse functions, that means that dy by dx is 1 divided by dx by dy, so that's 1 divided by cos y. Let's get this back in terms of x. We use the identity sine squared plus cos squared equals 1, rearranged to cos equals the square root of 1 minus sine squared x, and here we've got y instead of x, so this is the square root of 1 divided by 1 minus sine squared y. Now we just remember that actually sine y is equal to x, so sine squared y, that's sine y squared, so that's x squared, so this is 1 divided by the square root of 1 minus x squared, and that's the derivative of arcsine of x. Do something almost exactly the same for y equals arccos x, and write x equals cos y, then dx by dy equals minus sine y, and so dy by dx is minus 1 over sine y. And another way to rearrange this identity is as sine x equals the square root of 1 minus cos squared x. So this will give us minus 1 divided by the square root of 1 minus cos squared y, and cos y was x, so cos squared y is x squared, and this is minus 1 divided by 1 minus x squared. So the derivatives of arcsine and arccos are very similar, the only difference being this one is minus and this one is plus. Finally, we'll look at y equals arctan of x then, and that means that x equals tan y, so dx by dy equals sec squared y, so dy by dx is 1 over sec squared y. And the identity we need to use here is sine squared plus cos squared equals 1 divided through by cos squared to give tan squared x plus 1 equals sec squared x. So we can replace sec squared y here then with 1 plus tan squared y, and tan y is x, so tan squared y is x squared, and this is 1 over 1 plus x squared. And there we have the 3 results for differentiating the inverse trig functions. These results immediately give us some integrals, so the integral of 1 over root 1 minus x squared dx is arcsine x plus c, the integral of this is arccos x plus c, and the integral of this is arctan x plus c. All important results. So I just want to look at these two because they're very similar, and you might be tempted to come to a slightly wrong conclusion based on them. Because look, this integral is just minus this integral, and we know we can take a constant through the integral, so surely you might say, based on this, that arcsine of x is just equal to minus arccos of x. But in fact that wouldn't quite be right, and if you consider a right-angled triangle with hypotenuse 1, and let's make this side x, then we can see that the angle in here would have sine of that angle, would be the opposite divided by the hypotenuse, would be x. So this angle in here would be arcsine of x. And similarly, this angle in here would be arccos of x. So we can see whatever the angle is here, whatever the length x is, we actually have that arcsine x plus arccos of x is equal to pi by 2, or 90 degrees. Because these two angles in this right angle triangle will always add up to 90 degrees. So it's not quite the case that arcsine x is minus arccos of x, but actually arcsine of x is minus arccos of x plus pi by 2. So they differ, but they only differ by a constant. So actually this was wrapped up in the plus c here. This is an arbitrary constant, but just because we've called them both plus c doesn't mean they're always going to be the same when I compare them. So actually that pi by 2 has got lost in this arbitrary constant. In case that's not convincing, I've got the graph here of minus arccos x, which is the red one, and of arcsine x, which is the blue one. You can see one has just shifted up the page from the other one by pi by 2. And drawing these sorts of triangles is actually really useful, because if I wanted to work out something like tan of arcsine of x, well, here in general is arcsine of x, and tan of this angle would be the opposite side divided by the adjacent side. So it would be x divided by this side here. And by Pythagoras theorem, this side would be the square root of 1 minus x squared. So tan of arcsine x simplifies to x divided by the square root of 1 minus x squared. And similarly, if we wanted to simplify something like cos of arctan x, we do the same sort of thing. I just need a slightly different triangle because I want an angle whose tan ratio is x. If I'm thinking about this angle here, if I made this x and this 1, then the tan of this angle would be x over 1, which is just x, and the hypotenuse would be the square root of 1 plus x squared. So cos of arctan of x, well, that's arctan of x, so cos of that angle is adjacent divided by hypotenuse is just 1 divided by the square root of 1 plus x squared.